out on Collins. I be.
Hello guys, welcome to Everything You Need. In today's video, let's talk about PIR sensor, that is passive infrared sensor. Here I am using the term passive because it majorly works on principle of detection and does not radiate any energy. The PIR sensor allows us to detect when a person or an animal moves in or out of the range. All objects are including human beings at temperatures above 0 degrees absolute emit energy in the form of infrared radiation. The hotter an object is, the more radiation it emits. This radiation is not visible to human eyes because it is emitted as an infrared wavelengths. So, the PIR sensor is specifically designed to detect such levels of infrared radiation. A PIR sensor consists of two parts, that is, a pyroelectric sensor and a Fresnel lens. A pyroelectric sensor consists of a window with two rectangular slots and is made of a material typically coated with silicon that allows the infrared radiation to pass through it. So, behind this window, there are two separate infrared sensor electrodes, one responsible for producing positive output and other for producing the negative output. When there is no movement around the sensor, both slots detect the same amount of infrared radiation, resulting in zero output signal. But when a body like human or an animal passes by it, you can observe in the picture, it first intercepts the first half of the sensor. This causes a positive differential change between the two halves. When the warm body intercepts the other half of the sensor, the opposite happens and the sensor produces a negative differential change. By reading this change in voltage, motion will be detected. Now coming to the second part, that is Fresnel lens, you may think the Fresnel lens used here is not really doing anything. But in fact, this is what increases the range and the field of view of a PIR sensor. Its slim, lightweight construction and excellent light gathering capacity makes it extremely useful for making the PIR sensor small in size but powerful. If you see deep into this Fresnel lens, it consists of a series of concentric grooves carved into plastic. These act as individual refracting surfaces gathering parallel light rays at a focal point. As a result of these Fresnel lens, although small in size, the PIR sensor is able to focus light similarly to a conventional optical lens. In reality, to increase the range and the field of view of the PIR sensor, the lens is divided into several facet sections, each section of which act as a separate Fresnel lens. These different faceting and sub-lenses create a range of detection areas or zones interleaved with each other. In this way, we will observe a wide range of area to be covered within the small lens of the pyroelectric sensor. Now let's check the functionality of the PIR sensor by interfacing it with an Arduino. Let's create a circuit based project. Change the name of the project to interfacing and PIR sensor with an Arduino. For this project we need an Arduino, a PIR sensor, a small breadboard. When a motion is detected, let's blink an LED. For this we need an LED. Let's go to all components and take an LED. For this LED we need a resistor. Let's take a resistor and let's wire them up. Now I will connect this LED to the 13th pin of the Arduino. So let's connect the anode part of the and connect to red, give it to 13th and connect the 13th and connect the ground to the cathode part of the LED and change the colors to red. Now let's connect the ground part of the Arduino to the negative pin of the Arduino, negative pin of the breadboard. Let's connect the 5 volts pin of the Arduino to the breadboard and change its color to red. Let's connect the power to the power pin, and let's connect the ground pin to the ground bar and change its color to black. Now let's connect the signal part to the 12th pin of the Arduino. So let's go to 12th pin and wire it up and change its color to orange. Let's go to the code part. I have already made a code, so let's paste it. Here we have two variables, that is we have defined two variables, that is detect and an LED. Detect is given to the 12th pin, that is nothing but signal part of the PIR sensor is connected to Arduino, and 13th pin to the LED. So 13th to the LED. Here in the void setup we have made the pin mode 13 as an output, as it is connected to LED, and 12 to the input, as it is input to the PIR sensor from the Arduino. So here we have started the communication by 9600 as a baud rate, and into the coming into the void loop, here we have used the value variable, that is nothing but we have created a bool value with an initial value of 0, and we are reading the value of the detect by using the command of digital read and storing it in the variable. Detect will give the output as a high or a low, that is nothing but 0 or 1. When it is detected as 1, so that is nothing but detected as high, there will be a motion. When there is no motion, it will be act as a low, that is nothing but 0. So here in the condition, if val double equal to high, that is nothing but when there is a motion, we will print a message with a motion detected, and we will glow our LED with a statement of digital write of 13, high, and we will give a delay of 1000 seconds, 1000 milliseconds. And in the same way, if there is no motion, we will print the message no motion detected and keep the LED to be in the low state and with a delay of 1000 milliseconds. Let's try the code and how it works. See, here in the serial monitor you will observe continuous no motion. When there is motion, you could see motion detected message and an LED is glowing. So in this way we interface a PIR sensor with an Arduino. In the next video, let's see more detail about all the functionalities in the PIR sensor which you could do in the physical sensor. But out of our work, we will do some of the changes and simulate them by using some functions. Stay tuned for the next video. If you like this video, please like, share and subscribe to Everything You Need. Thank you.